are coming in. Couple of things. One, I have posted the quiz grade for everybody on Desire to Learn, so you have access to it. There has been a question regarding whether we'll go over the quiz. I will, but I will go towards the end of the class so that we don't spend all the time talking about the quiz and not the material. So I'll talk about the quiz towards the last of the class. For ones who are interested, the quiz was for 16 points, and the high was 16 and the low was 7.5. So high 16 out of 16, low 7.5 out of 16. So based upon that, you know where you fall, and quiz counts 5 points. Quiz 1 counts 5 points, but the total of this quiz was 16 points. Okay. So in this class, we'll be talking about lots of stuff. One of the things we'll be talking about is normalization, and we'll be talking about, I think, since we don't have a class on Thursday, I think the syllabus says the midterm is next week. So we'll be talking about a little bit about the midterm. Okay, one person says they can hear me. Can everybody hear me? Okay, all right. So again, as I said before, now look at the syllabus. There is no class on Thursday, July the 4th. The next class is on 9th, I think, and again, as I said earlier, if one or two of you are having a problem, there is really nothing I can do. Call the 800 number that I sent you. It's in Desire to Learn, and ask them to troubleshoot what your problem is. There's really nothing I can do. As far as the midterm is next class, which is next Tuesday, and that should be the 9th. And everything that we covered till today will be in the midterm. It will not be a take-home class test. It will be in class, and I will do like I did last time. I will send you the email you the test. We'll probably meet for a few minutes. I'm not 100%. We'll probably meet maybe 30 minutes or so, and then I will email you the test, and you'll have rest of the class to finish it. I tried to set up last time so that you can only upload the quiz. You can upload the quiz before 10 o'clock. I saw lots of you did not upload it till 10 o'clock. There were some which were really, really late. I'm going to talk to those Desire to Learn people and make sure that you will not be able to upload the things later than the time that I assign. And if for some reason Desire to Learn doesn't force you, if you submit it after the deadline, then I'm just not going to take it. I don't know all the details of I cannot talk about how many questions, how many points, all those are just I don't know, I haven't done it. So it will be primarily essay type questions. There will be very few short answer type questions because it's often booked on your home kind of test. So it is probably there will be no quiz, no multiple answer type questions. There will be no short. There will be primarily questions related to scenarios, problems, writing a lot of SQL, doing the database design, normalization that we're going to be talking about will be. There is a feedback that there was too little time for the quiz. I have taught this class several times in the classroom, and every time I gave 30 minutes, and being at home, I think it was more than enough time to do the quiz. So I don't agree with it. It is going to be the way it is. I have given this class, taught this class several times, and it's a similar kind of quiz I've given for less time than what I gave you that time. So we did not have less than 30 minutes. We had more than I sent it out around 9:15, and the deadline was 10 o'clock. So it's not absolutely true that there was less than 30 minutes. So I have the log of when the email was sent out, and it was around between 9:15 and 9:20, and you had till 10 o'clock to do it, and as I said, there are several of you who uploaded this thing after 10 o'clock. So I'm just giving you a heads up. If you upload it later than the time that I will assign this time, because Desire to Learn put a timestamp, you can see what timestamp it is telling you when you uploaded it. I'm just not going to take those answers, papers. So just make sure you upload it within the time frame that we assigned. Again, the final midterm will be based upon all the material that is covered till today's class, and we're going to cover a lot of material today. And so that's about the midterm. We'll be talking about the quiz. It will be towards the end of the class. So let's go on and talk about today. So today we'll be talking about normalization. I think we talked about a little bit about how to efficiently store data in tables, and there is a formal technique that is developed over the years that allows the best practice to store data, and these are described in terms of first normal form, second normal form, third normal form, Boyle's fourth normal form of BCNF and 4NF. Normal forms can be transformed from lower normal forms to higher normal forms, so we're going to go through that and see how process of evaluating and correcting table structure to minimize data redundancy. I think last class we talked about insertion, deletion, and update anomalies. That is basically what we are talking about, that we do normalize database tables to reduce those kind of update, addition, and deletion anomalies. Process for so we do by a series of normal form stages called normal forms, first normal form, second normal form, and third normal form. This particular, as I said in the beginning of the class, this particular normalization, I'm taking it from the book by Cornell, and I have uploaded these slides. You don't have to buy the book as long as you have the slides and you understand what we're doing. So, second normal form is better than first normal form, third normal form is better than second normal form. For most business database design purposes, 3 normal form is as high as needed in normalization. Highest level of normalization is not always the most desirable. So, as we're telling you, we will take an example. We'll convert the database into first normal form, second normal form, and third normal form. And as it's described here, for most business purposes, we stop at third normal form, even if there is fourth normal form, and there is fifth normal form, and there is BCNF. The normalizing the data is done with the most desirable, and we will see why, and we'll be talking about those little later. Denormalization produces a lower normal form, but in a lot of cases it increases performance with data redundancy. And again, we'll be so the concept we're trying to figure out is that up to third normal form is usually a good thing to do, but after as you go try to denormalize data more and more and normalize data more and more, it may not be the most desirable solution that we will come up with, and sometimes it might be also necessary to denormalize it. And we're going to go through an example to see all those. So let's look at an example, and this is how we will understand the normal forms. A company that manages building projects, and that's an example, but we're talking about a company that manages building projects, charges its clients the billing hours spent on each contract. So let's say you are running the IT department of a large manufacturer that is building several buildings throughout the city. It charges its clients the billing hours spent on each contract. The hourly billing rate is dependent upon the employee's position. So if you are building a building, there are different kinds of employees who are working in this particular. There might be somebody who is a welder, somebody who is a mason, somebody who is a supervisor, somebody who is installing an elevator, somebody who is doing electrical work. So all these employees have different billing rates. Periodically, a report is generated that contains information as displayed in 6.1. So if you look at this table, we will see here is the projects that this particular company is running, and the projects are Evergreen, Emberware, Rolling Tide, Starflight. So these projects has a number, that is the project number that is associated with each project. And these are the employees: June, John, Alice, William, David. They are working in project number 15 or project Evergreen. Annalise, James, and Darlene are working in project Emberware. And as you can see, each one is a different title. June is a electrical engineer. John G is a database engineer. Alice is a database designer. William Smithfield is a programmer, and David H is a systems analyst. So as I told you, for each project there are different kind of people, or different kind of employees or resources who are working on it, and their charge hours are different. And this spreadsheet keeps track of how many hours that they have worked for this particular project, so that the company can bill the clients. So this is the tabular representation of the report that was created. And this is the record layout. So you can have a report which shows how exactly the billing has happened. So for Evergreen, for the services of all these 1, 2, 3, 4, 5 employees, each employee has a charge hour, and each employee has number of bill hours that they have billed to this particular project. So the total they're charging to Evergreen is $10,573.50. So you can see this is the report layout. So structure of data set in 6.1 does not handle data very well. Okay, so we'll see. If you really look at this example, you'll see that Evergreen, these are great, this is great for doing a report, but when you are storing data, and I think we'll go in and look at it. So let's look at this again. Here you can see Even if in the spreadsheet we have written evergreen only once, but if you want to store it in a database, what you have to do is you have to enter project number and project name for every row that is blank. Every row that is blank is basically we're saying that we know that the project number and project name is 15 and evergreen, or 18 or Ember Web, so or 22 or rolling tide, 25 and Starflight. So when we store this information in a database, the project name and project number are repeated again and again and again. And that's what it's we are storing the same information again and again and again and wasting a lot of space. So what is the better way of doing that so that we don't store the information that is there again and again and again, repeating information. So the objective will be to reduce as much repeat as possible. So each table, so the normalization process, when we take something like we saw in 6.1, each table represents a single object, so subject. So we want to store data in such a way so that each table represents a single type subject. No data item will be unnecessarily stored in more than one table. So these are the basic principles. When we take a spreadsheet like we're seeing there, and we say we are going to convert it to a normalized set of database tables, each table must represent a single subject. No data item will be unnecessarily stored in more than one table. All non-prime attributes in a table are dependent on the primary key. So this is another, again, we're going to go into detail. So these first two are kind of philosophical, that every table must contain a single subject. No data item will be unnecessarily stored in more than, so we are not duplicating information storing in multiple places. All non-prime attributes in a table are dependent upon the primary key. So if you have a table, the attributes which are not primary keys are dependent upon the primary key. That means the primary key should determine every other column in the table. Each table is void of insertion, deletion, and update among others, as we said last time. And again, we're going to go through an example so you'll see it. So the objective of normalization is to ensure that all tables are at least in 3 normal forms. Higher forms are not likely to be encountered in business environment. Normalization works one relation at a time, progressively breaks tables into a new set of relations based upon identified dependencies. And again, I say the goal is that a primary key should determine every other column in the table. Okay, so to do that, we talked about the functional dependencies. I think we have talked about that. And I think we have already talked about functional dependencies in our previous class. I think with B, fully functional dependent on attribute A if each value of A determines one and only one value of B. Example, project number and project name. As you said, in the example we showed here, for a project number, 15 determines that project name is evergreen. 18 determines that the project name is Ember Web. 22 determines that the project name is Rolling Tide. 25 determines that the project name is Starflight. So that's exactly what we are saying here, that this is project number is functionally determining project name. Okay, so, and I think we talked about this a little bit more, and we're going to use the example. Conversion to first normal form. So we have this spreadsheet that we have taken, and we are now going to convert it to a first normal form. The first thing is repeating groups. Group of multiple entries of same time can exist in a single key attribute occurrence. Universal table must not contain repeating groups. Normalizing stable structure will reduce data redundancy. Okay, so let's go and do it. Number one, eliminate the repeating groups. Eliminate nulls. Each repeating group attribute contains an appropriate data value. Step 2, identify the primary key. Must uniquely identify attribute values. Identify all dependencies. Okay, so when you try to do the normalization, first step is to eliminate repeating groups. Eliminate nulls. Each repeating group attribute contains an appropriate data value. So we'll see how we do it. Identify primary key. So you must identify what is the primary key of this thing. Must we identify attribute values. Identify all dependencies. So let's go and see how we do it. So here is the first table in fast normal form. So in order to get the table in fast normal form, what we did was, we said, as I showed the last time, instead of saying 15 evergreen and blanks, which a database doesn't know what a blank is, we just fill it out. We say 15 evergreen, 103 June, 15 evergreen. So we enter everywhere there was an empty value in the previous example that I showed. It is now filled with values which looks like duplicates. But this is, we cannot have blank columns in a database. And so this is the first step to convert it to a table in fast normal form. And again, as we know, fast normal form is really something that we don't want to use. We must go to at least third normal form or BCMS before we can use something for practical uses in a business application. But taking the example that we showed, this goes to this as the fast normal form. All right. Second, depicts all dependencies found within the given structure. Helpful in getting bird's eye view of all relationships among table attributes, make it likely that you will overlook an important dependency. So the first step is that after you have converted, taking the spreadsheet, removed all the nulls and blanks and all that, and convert it to something like this. Now you figure out what are the dependencies. And that's the steps that we are going to do. First step we did, we removed all the nulls, like eliminate repeating groups, identify primary key, identify all dependencies. Okay, so here we come to the dependencies. And this is, I think, from this point you must understand everything. I think, some of these we are talking about till now is, the theoretical and all that kind of stuff. So maybe, but first you must, like you say, remove repeating groups, remove nulls. So we took all the blanks out, made it pretty, and filled all the empty spots. We got the first normal form. Then we are looking at what dependencies are there. The dependencies are, and you can see in this book, that project number and project name determines project number and project name determines project number determines project name, project employee number. Let me go through each of them. Hold on. 1 second. Okay, so we look at this thing. The primary key attributes are underlined and bolded in a different color. The primary key, as you say, identify the primary key for this table. The primary keys are project number and project name, because we identify, you can identify a project either by project number, which is unique, or project name, which is also unique. So those are the primary keys for this particular one normal form. It is also possible that there is partial dependency between project number and project name. So in order to know the project name, you can, if you know the project number, you can determine project name. If you know the employee number, you can determine employee name, job class, and charge hour. So these two are the key, and the goal is to find all dependencies. And we know that from project number, we can find project name, so there is a partial dependency. From project employee number, we can find employee name, job class, charge hour. From job class, can determine charge hour. Since job class is not a primary key, and we call it a transitive dependency. If one primary key determines another primary key or another set of attributes of a first normal form, then it is called partial dependencies. If two columns which are not part of primary key, then it's called transitive dependency. Okay, so let's see who did not understand this, because this is, there will be certainly a question in the midterm which will say, here is an example, convert this to first normal form, second normal form, third normal form. That is given, because that's what I ask all the time. So let me ask who did not understand this. So we took a table, we took a spreadsheet. First we identified the primary keys, employee number and employee name. We know project number and project employee name, project number and employee number. And we know that project number determines project name, employee number determines employee name, job class, and charge hour. Job class determines charge hour. Since job class is not part of the primary key, this is called a transitive relationship. Since project number and employee number are part of the primary key, this is called a partial dependency. And in order to convert something from first normal form to second normal form, you must identify the primary key, you must understand and find the partial dependencies, and you must find the transitive dependencies. And then we'll say what exactly we're going to do with it. Okay, let's ask this, because this, again, the reason I go to another book for this is because this book does a lot better job of explaining this than the other book, and the other book is just too confusing, at least for me. So, who didn't understand this? Who's not following it? Okay, everybody is following it, so I'm detecting it that everybody is following it. That when you get it, first stop will be to find project number and employee number. Project number and employee number determines everything else. You can so project number and employee number is the primary key. project number and employee number together determines project name, employee name, job class, charge hour, and hours. Project number determines project name. Since project number is part of the primary key, that's a partial dependency. Employee number determines employee name, job class, charge hours. Since employee number is part of the primary key, it is a partial dependency. Similarly, charge hour job class determines, like, if you are an engineer, your rate per hour is 50. If you are a draftsman, your charge per hour is 35, and that's the dependencies. So let me ask again, everybody following it, because it will get more and more complicated as I go to the next slide. I see no questions, so everybody is good with it. All right, moving on. Okay. Again, all key attributes are defined, non-repeating groups. All relational tables satisfy 1NF requirements, but I don't think anything that we do is over 1NF. We don't. So then, once we have found out that what the two dependencies are, the partial dependencies and transitive dependencies, what we do is in the second number form, we eliminate partial dependencies. So let's see how we do that. So we had partial dependencies, project number, determine project name. So what we do is we create a table of project called project, with project number and project name. So we create a table of that. Similarly, we create a new table called employee, with employee number, employee name, job class, and charge category. Then we say, okay, we have done that. Now we have a table called assignment. We have, as you see, employee number determines employee name, job class, and charge hours. But it doesn't determine charge hour is charge per hour, but it doesn't determine the hours that a particular employee worked. So if you look at it, what we are missing is we are missing the hours, because we took the two dependencies and the hours. Now what we do is we create a new table, which is project number, employee number, and put the hours there. We call it assign hours, but it's a new table called assignment. So instead of taking one table that we had in the previous example, we had one table and we had two partial dependencies. To get rid of the dependencies, what we did was we created a table called project number, project name. That's one table. Then the second table is this. Employee number determines employee name, job class, and charge hour. So that becomes another table called employee. So we have a project employee. Then only thing left is this hour. So we somehow have to keep the hours. To keep the hours, what we do is we take the primary key, that is project number and employee number, and create another table, another column, and call the table assignment table, which contains project number, employee number, and hours. So this one table is now broken into three distinct tables, like we have done here. Three distinct tables, and this thing is in two second normal form. The table is in second normal form, and it is in first normal form, and all partial dependencies are eliminated. There is no partial dependencies. So starting with a first file where we had like this. Now we have taken this and we have said, okay, to store its information efficiently, we must convert it to something like this. Instead of one flat file, we have now three tables. And we have eliminated First, we made it first normal form. We removed all repeating loops. We eliminated any blanks, nulls. Then we found the primary key, which was employee project number and employee number. Then we found two dependencies, partial dependencies, like project number determines project name, employee number determines employee name, job class, and charge hour. We looked at the transitive relationship, whereas job class determines charge per hour, and the difference between partial dependency and transitive dependency is partial dependency, you have the primary key that is determining other attributes. In transitive relationship, a non-primary key is determining other attributes. So we took that in, then we broke them. In second normal form, we eliminated the functional partial dependencies, and we came back with 3 tables. So from 1 table, we are going to 3 tables. Okay, who doesn't understand this? Either everybody is understanding everything or everybody is understanding nothing. But I have no way to know. Do you all follow? Okay. You can bet on that there is going to be a there will be going to be a question on this, at least one, if not more than one, in the next Tuesday. Okay. Assignment hours is they're just, instead of, they could have called it hours just to make it less confusing. They created something called assign hours. It's not really, it's just to make it more appropriate that you were talking about assignment table. So this is for a particular employee, for a particular project. These are the number of hours the employee has charged to the project. Okay, so here comes, there are questions always. What is the second normal form? The second normal form is if the relationship is in first normal form and there are no partial dependencies, as I said earlier. Okay, so then the next question is, how do we get to third normal form? And I think we get to third normal form by eliminating transitive. So by eliminating partial dependencies, we go to second normal form. By eliminating transitive relationships, we go to third normal form. For every transitive relationship, writes its determinant as primary key of a new table. Determining any attribute whose value determines the effect. So let's just go and see it. Okay, so what do? We do is we have project number with project name. We have job class. So the transitive relationship is job class and charge hour. Okay. So what we do is employee. Just 1 second. I'm missing a slide or something here. So. Make a new table to eliminate transitive dependencies. for every type of transitive dependency, writes its determinant as primary key for the new table. So the primary key of the new table will be job class, and we basically what we did was we took the primary key of the job class as the primary key because so let's go back. The transitive relationship is job class is determining charge hour. So we go to this. So we have three tables here: project, employee, and assignment. There is no transitive relationship. There is no transitive dependency in project or assignment. So we are pretty good with that. Only table that has a transitive relationship is job class and charge hour. So we need to get rid of job class and charge hour in this format that it is right now in. So what we do is we take job class and charge hour and make it a table of its own. And once we do that, what will happen is the employee table now is broken into two tables: employee number, employee name, and job class. And job class now becomes a primary key. So the first step is like you say here, make anything that is in the left-hand side of is a determinant as the primary key of the new table. So this became the primary key of the new table, job class, and there is a charge hour for each job class. So they become one table. And this table, employee, now has employee name, and job class as the key that is matching putting these two things together. So from 3 tables, now we go to 4 tables, and this is in 3NF. So let me again repeat it again. We got here from 1NF to 2NF by getting rid of partial dependencies. The next step is to reduce transitive dependency. So in order to do the transitive dependency, first thing you need to do is make the determinant as the primary key. So we break that, we create a new table, and you can, as you said, it is called the new table is called a I think we're calling it a new table. We're calling job table. So job table contains job class and charge hour. So those are the two, because job class determines this is the primary key and this is determining charge hour. Now we have only 2 things left here: employee number and employee name. But you must put that primary key back here again so that these two tables are related. So you have now project table, employee table with employee number, employee name, job class, and you have another table for job class and charge hour. And that's what you end up here. And this is called the third normal form. And as I was discussing, third normal form is usually most widely used in businesses. So what I do day-to-day in my primary job is to help engineers develop all those things, but to go from the second normal form to the third normal form is to remove transitive dependencies, and we can remove transitive dependencies by taking the determinant, making it the primary key, and then splitting the table that has the thing, the primary key into 2 tables. So we took a spreadsheet, we converted it to first normal form, then we converted it to second normal form, then we converted it to third normal form. And I think we are pretty close in We will probably talk about a little bit about BCNF and fourth normal form, but as far as any questions in the class comes, I think most of the time I will stick up to high level form, as I said in my before. High level form is where most companies stop in normalizing their data, and really fourth and fifth normal form are hardly used, and it's a lot of times it's even detrimental for projects to go beyond three normal form. Okay, table is in third normal form when both of the following are true. It is in second normal form. It contains no transitive dependencies. Table structure should be cleaned up to eliminate initial partial and transitive dependencies. Normalization by itself be relied on to make good design. So yeah, we can do. Let's see, what else we want to talk about this. We have talked about it. Okay. So what I'm going to do is we're going to spend another 10 minutes or so on concepts in third normal form, BCNF and fourth normal form and stuff like that. I'm not going to go into a lot of details of that because again, those are more theoretical and of theoretical interest than of practical interest on doing any work. If you don't understand how to do this, going and take your tables, try to break them up into third normal form and BCNF and see where it will go. We will talk about a little bit more. Then I think I'm going to go till 8:40 or so. Then we'll come back around 8:55, and then we'll start chapter 4 and see how far we can go on chapter 4. And towards the end of the class, we will be talking about the quiz. Okay. Tables in the perform suitable in the business transactions, and that's the reason I'm not really interested in anything else. High normal forms are useful on artisans. 2 special cases are third normal form and Boyce-Codd normal form and fourth normal form. Okay. A BCNF, every determinant in a table is a candidate key. Has the same characteristic the primary key, but for some reason, so every determinant in the table is a primary key. So in order to convert something to BCNF, every determinant has to be a primary key, and it is a candidate key. That means it can be the primary key, but for some reason was not chosen as the primary key. When the table contains only one candidate key, B3NF and BCNF are equivalent. BCNF can be violated only when table contains more than one candidate key. And I think again these are basic theoretical concepts. I'm not going to go a lot more detail into it. Most designers consider BCNF as a special case of 3NF. A table is in 3NF when it is in 2NF, and there are no transitive dependencies. We already talked about that. Table can be in 3NF and held to be BCNF, and I think I'll just not going to get a detail into this because again I'm not going to ask you to do anything beyond 3NF. Just learn that there is something called BCNF and there is something called 4NF. A table is in fourth normal form when both of the following are true. It is in 3NF and no multiple sets of multi-valued dependencies. I think I'm not even going to go into this too much because it's just too confusing. Okay, so just know there is something called 4NF, and sometimes we do it, but as I said, most business needs we don't talk about BCNF or 4NF, 3NF. One is more than enough, and we're not going to I'm not going to ask you anything about them. Normalization and database design. Normalization should be part of the design process. Make sure that the proposed entities meet required normal forms before table structures are created. Okay, this is important. So for all your projects that I have asked you for your group projects, The projects, now you probably know what I'm looking for as we go into it. Where I'm looking for normalized set of tables. So there should be at least 8 to 10 tables. I think I told all of you. And when you design these normalize these tables, they must be normalized, at least in CMF. And before you create the table structure, the conceptual design is giving me a set of tables which are normalized and doing it in a video and showing the relationship between those tables. I think that's what a conceptual design is. But as far as, and I have updated the syllabus with new deadlines, and so the deadlines are quite far off. We probably not anything due soon, so you can look up when the conceptual design is now due. And there was a typo on the midterms and finals, how many points it was. I fixed that. So midterm is 25%, final is 25%, project is 35%, quizzes are 10%, and class attendance is 5%. And I think I have so many real-world databases have been improperly designed and burdened with uneven. You may be asked to redesign and modify existing databases, but the basic idea is that when you learn these normalization techniques, and we talk about the ER diagram, which we are going to talk pretty soon, you are going to know how to. Okay, so we are going to be talking about ER diagram, normalization procedure, and all that kind of stuff as part of the next chapter, because I think this we're going to talk about in chapter 4 of going, whatever his name is, going an hour. So that is how much I wanted to talk about. There is a question which says, what is the difference between conceptual design and ER diagram? There is none. They're the same thing. Conceptual design and ER diagram are the same thing. And as we talk about those things in more detail, you will get that. Okay. From my experience, lots and lots of students, and say I have been teaching this class for about a couple of years now, and do not get how to normalize tables. So what I'm hearing, and I've asked it again and again, you guys seem to get it. So that's great news that you can. But if you don't, I'm more than willing to go over it or explain anything that you didn't get. But do practice and make sure you take a class file or a spreadsheet, and we'll be able to convert it from flat file to normal form. So be able to do the same thing with your project thing, and okay, so I think we'll not go through all of these slides because this is going to talk about some of the other stuff that is kind of repeating in the other book. So anybody has any other questions? And I say we'll go to chapter 4, then we'll go to, chapter 4 is a small chapter, so hopefully we can go very quickly and finish that today. And then we'll be talking about the quiz. Yeah, chapter 4 is a relatively small chapter, and the goal is to finish it today, and then talk about the quiz, talk about the final, and talk about the midterm, and take it from there. Okay, so what I'm going to do is I'm going to, it's 8:39. We're going to take a 15 minutes break. We'll be back around 8:55, and we will go through chapter 4, and I think we'll go probably 40 minutes or so, and then we'll talk about the quiz. And in the quiz, primarily, lot of you missed the last two questions, and that's the reason that grade is as some of you have a lower grade because so just practice more and more of SQL because I see a lot of mistakes in the SQL, and again we'll talk about it. Okay, see you around 8:55. Okay, we'll get started. I'm trying to finish chapter 4 today, and then we will talk briefly about the quiz, and then we will talk a little bit more about the final exam, if anybody, the midterm, if anybody has any questions. Then we'll wrap up for tonight. Okay, so chapter 4 is about database design using normalization, and to design databases updated to store data received from another source, to use SQL to access table structure, to understand the advantages, disadvantages of normalization, to understand denormalization, to design read-only databases to store data from updatable databases. So let's talk about that. Okay, so some of the common design issues that we face in real life is multi-value, multi-column problems, inconsistent value problems, missing value problems, and general purpose remark column problems. So in this chapter we are going to talk about, we have received one or more tables of existing data. The data is to be stored into a new database. Should the data be stored as received, or should it be transferred from storage? So, like what exactly we were telling about was in the previous coronal book, the chapter 6 of the book that we just covered. We were talking about that we have received a spreadsheet, and we took the spreadsheet, we converted it to first normal form, then we converted it to second normal form, then we converted it to third normal form, and obviously we can convert again to DCNF or 4NF, but we said that for most commercial applications, third normal form is the appropriate level of detail that we need. So here we are saying we have got a similar form, similar kind of data from some source. And what do we do? Do we store the data as received, or we transform it? And basically we are talking about how many tables. Let's say we have two tables called school data with school description and buyer, and we have a buyer table with buyer and the department that he or she buys for, where school data buyer must exist in buyer.buyer. So we're saying that there is a referential integrity between these two tables, where says school data buyer must exist in buyer.buyer. So there is if the buyer doesn't exist in buyer table, then that buyer doesn't exist in school data table. So the question is, should we store these two tables as they are, or should we combine them into one table in our new database? Assessing table structure. So we're doing some of the count rows and examine columns, examine data values, and interview users to determine multi-value dependencies, functional dependencies, candidate key, primary keys, foreign keys. So when you get some of the data, we kind of do some of this stuff. So here is, I think, to count rows in a table. So we got something, we want to find out how many rows are there in this table. We have a function called cont'd. So select cont'd as number rows from school data. So if you do select cont'd as, so the result of cont'd is display the number rows from school data that will give you the total number of rows in school data table. Examining the columns. So we got some data from some source. So we're trying to figure out how we're going to store the data, and obviously we are going to look at the normalization techniques that we have learned in previous in today's class. But we are first finding out how many rows of data that we have got, how big is the data that we have received. So to count the number of rows that are in the database, we say select count star as something from the table. To determine the number of types of columns in a case table, use the SQL select statement. To limit the number of rows received, use the select. To determine the number and type of the columns in a table, so SQL select, use and SQL select statement. To limit the number of rows retrieved, use SQL top expression. So, some of the things we are trying to also introduce some of the cost concepts. If you want the top 10 rows of school data, then you say select top 10 star from school data. Again, these are not that not extremely important concepts, but basically they're saying, well, I can have, if you say select the column names, you'll find out what is the column structure. Checking validity of assumed differential integrity constraints. Again, two tables with assume, and here the constraint is that if you have a buyer in school data, must exist in buyer.buyer. So you cannot have a buyer name in this table and they're showing the differential integrity. Not terribly. To find any foreign key values that violate the foreign key constraint, we use select buyer from school data where buyer not in, select, and I think lots of you in the quiz made this mistake. To find any foreign key value that violates the foreign key constraint. So if you say select buyer from school data where buyer not in, select school data.buyer from school data buyer where school data.buyer equal to buyer.buyer. What does this do? I mean, just look at the SQL statement. The SQL statement is trying to find out that if there is any buyer who is not, there is no any buyer in buyer table who is not in school data table. So to do that, we are writing, and this is where a lot of you made a mistake. So it's just see this. Select buyer from school data where buyer not in, buyer is not in, select school data.buyer. When you do buyer not in or buyer in, this one and this one should match. These two columns are the same. This is buyer, this is buyer. This cannot be, and probably half of you made this mistake that when you are doing where buyer or where something in, customer ID in, then you select something else from this table, not customer ID. You must select customer ID because when you say select where customer ID in, select customer, it should be customer ID. These two things should be exactly the same. This and this should be same. So that's half of the problems that we had, and that's the reason a lot of you got points. When looking at the database design, you look at whether the database is, so this is how we check the referential integrity, is the referential integrity is maintained. in the tables that we just received. The database design, if it is updatable database versus the read-only database. For updatable databases, we normally want BCNF. For CNF, I think for read-only databases, we may not use BCNF. Okay, so this is an important concept. So what is the updatable database versus what is the read-only database? A read-only database is one from where you only read information, but you do not write anything back. The example of such databases are, let's say you are verifying somebody's social security number, whether they are eligible to work in this country. So you type in an employee ID or your social security number, here comes some information. You do not go back and update anything to social security database. So that is an example of read-only database. Let's say you are buying stuff from Amazon, and Amazon has a database where they are tracking the spending behavior of people. Or they have so they are looking at not at an individual level, but they are looking at a group level. How is sales of iPad 5 going? And that database is usually a read-only database because you are looking at information that is already gathered and it's presented to somebody. But when you are buying the iPad, that is a transactional database because you are updating the quantity of data of the iPads that are available, the price and all that, and the shipping address and all that kind of stuff. So the buying portion of the iPad is a updatable database, but if Apple is tracking what is their sales in different regions, different countries, that's a read-only database because at this point they are not really interested in updating anything, they are really interested in tracking the information. If you are working for a company which is selling something, they are probably doing the updatable database, but the CEO of the company, when they are looking for information about how the company is doing, how the sales are going, that's probably the read-only database. So the design of databases based upon whether they are used for transactional purposes or used for business intelligence, or those are read-only databases. For updatable databases, like when you buy the airline ticket, or whether you are reserving a car, or whether you are buying something from Amazon, or you're buying something from the nearest grocery store, or you're buying something from your nearest department store, all these are updatable databases. And for updatable databases, if you have a database, so if you are doing a project that is designed for consumer, you're doing things, you're updating the database, you are taking things in, inserting things into the database, removing things from the database, you are checking in, checking out kind of functionality, that's the updatable database. If you are basically looking for information, trends, buyer habits and stuff like that, those are mostly read-only databases. So when you read-only databases don't need to be normalized, or it might sometimes it might make sense not to normalize them compared to updatable databases. Okay, normalization. So we talked about how to do normalization, and the advantages and disadvantages of normalization. Eliminate modification anomalies, reduce duplicate data, eliminate data integrity problems, saves file space. More complicated SQL, as we said, showed in the example that we just did. Instead of having one table got converted to 4 tables, and obviously that is writing SQL against 4 tables, as we know, is not more complicated than writing SQL against 1 table. extra work for the DBMS means slower applications. It might be slower, but on the positive side, we reduce duplication data. We save a lot of space where instead of storing the same information like the project number and the project name hundreds of times, millions of times, and storing a lot of investing a lot of disk space. We spend less disk space. We reduce the anomalies that can happen if you update in one row and don't update the whole thing in another place. Like somebody comes in and they have the project name, number, and project name. They update it in one row and forget to update it in the third row, and that causes the database to be incorrect. So here is an example, and now I think we're going to do just a little bit of the things that we already talked about. Here is a non-normalized table, equipment and repair. Equipment repair uses equipment number, equipment type, acquisition cost, repair number, repair date, and repair cost. And we normalize into equipment item table and repair table, where we broke it down the same way we broke down the earlier. We saw it in the previous example. This is okay. We copy data from one to the other. There is some of the other things that we are getting into here. Is insert into. One of the statements we didn't learn. One of the things we didn't learn in the previous, when we were completing all the sequels, is insert into. So we will get into a concept called insert into. So if you want to insert some data into a table, you say, or you want to add some new rows into a database table, you say insert into equipment item table, select distinct item number, equipment type, acquisition cost from equipment repair table. So insert into, so this is the syntax. You have insert into the name of the table that you are inserting to, equipment item table, select distinct item number, equipment type, acquisition cost. So let's look at what equipment item table looks like. Equipment item table has 3 columns: item number, equipment type, acquisition cost. The book has written like this: select into. If you do not put any columns here, it is assumed that you are entering item number, equipment type, and acquisition cost. But it's a good practice. I don't like this slide to put item number, equipment type, acquisition cost here in parentheses. Then say select distinct item number, equipment type, acquisition cost from equipment repair. So I will, if I'm asking the question, I'll assume I'll be happy if you put, because it's a lot easier to say when you are saying insert into the table, and what are the columns you are inserting into. So you put the name of the columns here, comma, 3 columns. Then you say select. This is one. This is one. This is one from equipment type. So this is how the syntax for. This is how the same syntax for insert works. Similarly, insert into repair, the 3 column with the 4 column names are repair number, item number, repair data, repair cost. I would like you to put that in parentheses. That's the best practice to do it. Then say select repair number, item number, repair data, get repair cost from equipment repair. Okay, so you got the insert. That's one of the simple things we didn't go. The book kind of breaks it up into a lot of different things. And Mine is only different is when you say insert into equipment item, put a parenthesis and put the column names that you are inserting into. That's the only difference. So the column names are item number, equipment type, and acquisition cost. I want it to be explicitly defined here, and then everything else remains the same. Is that clear? I'm explaining it again. What it will look is insert into equipment item, parenthesis, item number, comma, equipment type, comma, acquisition cost, parenthesis end, then select whatever you have. So it should say select, let me write down. Oh, sorry. Insert into equipment underscore item, parenthesis, item number, comma, equipment type, comma, acquisition cost. That's it. That's the only difference. Then you say select whatever. Everybody got it? That's the only difference. I want to okay. So the only difference is I'm trying to okay, so only difference is you just put a column, parentheses here, write down the put a parenthesis here, put down the name of the columns that you are inserting into. Insert into equipment underscore item, and then name of the columns, comma, comma, comma. That's it. That's what I'm saying. Put the three columns. Okay. BCNF is used to control another. Okay, we are not doing, okay, we're not talking about, okay. One of the concepts that we're trying to introduce here is the read-only database. As I said earlier, read-only databases are read-only databases are non-operational databases using data extracted from excuse me, operational databases. So for read-only databases, they are used for querying, reporting, data mining. They're never updated. And The great example is what we are doing in NSA surveillance program that we are talking. We are in the news right now. NSA is collecting information about everybody's phone calls, metadata, emails, or whatever it is. They gather all this information to find some trend, who is doing what, and is there anything that they can learn from it. They are not really updating anything. They are not really going in and saying, oh, they are only querying the database to find some information out of it. And that's the perfect example of a read-only database. They gather all these 3 billion transactions that are happening every day, store it in a database, and then trying to find something out of it. And this is read-only, non-operational database. They don't really do anything with it other than querying the database, writing reports, that the data mining, finding some information out of it. They are never updated. The data, we do not really go in and update it because the data is already happened and there is nothing, the phone call has already happened, there is nothing to update it. There may have been new data imported from time to time. So the same thing like the dashboard for a chief executive officer. The chief executive officer is looking at information about sales, about expenses, and these are all things that has already happened. It is not something that he or she is looking to update anything. It's basically giving them a snapshot of our sales in particular quarter, particular product line, particular category, particular salespeople, our expenses, based upon offices, departments, whatever information, projected sales and stuff like that. So those are information that we don't usually update, but we only get it. And for those kind of databases, which is primarily read-only database, your denormalization. Normalization is something seldom an advantage. We do not normalize those. But it is even more advantageous to denormalize them because the advantage of normalization is to have faster queries, whereas the job, when you denormalize them, it is usually more easy to aggregate them rather than, because when you're looking for read-only databases, it's mostly for read-only databases, normalization is seldom an advantage because application processing speed is more important. We have tons and tons of data, we want to get something out of it. So denormalization, it is important that we get faster response time because we have so much of data rather than be efficient in storage and worrying about addition, deletion, and update anomalies which doesn't exist in a read-only database. The read-only database does not have addition, deletion, insertion, and update anomalies. It processes lot more data than a updatable database. Therefore, in read-only databases, it is more appropriate to denormalize them. Insert into read-only database, many copies of many copies of okay, so I'm not going to get into that. Okay, I think not very important, these things. Okay, let's talk a little bit about missing value. Null value is a value that has never been provided, so you can, a lot of times we say a particular column, whether it can store null values or it can't store null values, so that's important too. Null values are ambiguous. Many indicate that the value is inappropriate. Date of last time result is inappropriate for mail, And sometimes when you are designing databases, you can say whether a column can have null values or it cannot have null values. Not very important. Checking for null values. If you want to check for null values, then you can say select count whether quantity is null. So is null is a value that you could use. Okay, I can hear two people said they can hear me. How many people can hear me? I'm right in front of my mic, so I'm just trying to figure out. Okay, so the two people who are having problems, please call 98 number, because really, as I said, I am as close as I can be to the mic. Checking for null values, use the SQL keyword is null to check for null values. So if you have null, you say select count as whatever, but the keyword is where quantity is null. So if you're trying to find something of null, means you can say where quantity is null. Okay. So again, this is kind of a general topic. This is really the meat of this class that we had was normalization. But it brings up a couple of big topics. One is insert into how do you insert values into a table. So it talks about the syntax. I think we'll certainly have questions on that. On inserting values into tables. We talk about null values. When we're designing databases, you should be talking about whether there should be a null should be allowed, whether it can be empty or not, because that's something you can specify when you're creating database tables, then whether you allow null values or not. You can also talk about denormalization, and we talked about read-only databases. And the idea behind read-only databases is that you have databases which are not updatable, like the MSS stuff we talked about. They are not usually normalized because the speed is of more essence. We really don't care about update, delete, and insertion anomalies. We don't care about data integrity that much. We care about processing huge amount of data in a short period of time, and that requires that it be not normalized. This class will primarily focus on application data, not read-only data. So for that, most of the things that I will ask in this class for you to do will require normalization. And this is just to give you an idea that normalization is not appropriate in every case. But for this class and for all the things that we will be doing, it will be it will be for all the large projects, we will expect it to be normalized because we are going to do transactional databases, we process a lot of stuff, we update a lot of stuff, insert a lot of stuff, and delete a lot of stuff. And that introduces the different anomalies that we are talking about, and it is critical that we increase the data integrity part of it, and that's the reason we're going to do normalization. This is probably the smallest chapter that we have, and it just gives you few concepts that I'm interested in inside read-only databases, and few things that are somewhat important. But I will insist that you understand the first part of the lecture today, which was regarding the normalization. That is very important. we introduced few things. We introduced the count concept, we introduced the top concept, we introduced the insert statements, we talked about the read-only databases, we talked about the normalization. I think we talked about why normalization may not be good for read-only databases. So that's as much as I wanted to talk about for the chapter 6 and chapter 4. Now we are going to, anybody has any questions before we move to if we move to the quiz now. Before we move to the quiz, okay, let me just, before we go to the quiz, let me talk about the midterm next time. The midterm will be, again, I probably will talk for a little bit. We might start chapter 5 for 30 minutes or less. The test will be for 1.5 hours, and it will be, I will email it to you, and I'll give you 1.5 hours. I will strictly enforce that in 1.5 hours, and maybe I'll give you 5 more minutes to upload it. So after 1 hour, 35 minutes, if you did not upload it to Desire to Learn Dropbox that I would have created, I will not accept that test anymore. If you have a problem during that period of time, you send me an email in Desire to Learn, or send an email to ajema1@gsu.edu, whatever it might be, as long as I have it within 1 hour and 35 minutes. Because the test will be primarily chapter 1 through 4 plus chapter 6 of Cornell that we covered today. So there will be 5 chapters, 1, 2, 3, 4 of Cranke and chapter 6 of Cornell. We will, it will be primarily, there will be probably no multiple choice questions. It will be all essay type questions. I will like that everybody has a scanner to scan it in and upload it, because I think there will be a lot of drawing that we have to do. Like, unless you are really good and you don't need the drawing and you can do it you can probably do it just by hand if you're really good at it, but I will think that it will be good if you have a printer and a scanner that you can scan this thing up and upload it to the Dropbox. Anybody has any problem with that? Okay, well, if you don't have a scanner, then what you can do is you can write in a piece of paper and type it in later on into, only thing you things that I'll need a scanner for. It will be good if you you look at the figures that we had. If you draw it in a piece of paper, and then type in exactly what tables you are doing at the end, I think it's okay for me. Either. If you can scan it in, okay. If you can't scan it in, that's okay. Yes, I think it will be good if you can scan it in and send it. If you can't, that's okay also. Okay, well, I will not put that requirement. You will be asked to do the third normal form design, and as long as you can do it in a piece of paper and then type it in what exactly you found it in the answer sheet, that will be fine. we will be doing normalization, and it can be done by drawing, or it can be done. You can draw it in a piece of paper on your desk, and when you submit it, you can just submit me the tables that you come up with. So no, there is not going to be any template for any drawing. It's going to be basically the drawing that we did today. So I think you can easily come up with your third normal form database or tables layout, and you probably don't need a drawing. So I think it'll be fine. There's no study guide. It's going to be whatever we have covered. So primary things to focus on is all the SQL. There will be lots of SQL, and there will be lots of normalization. And there will be few short answer questions which are related to topics we have covered. So as long as if you know the SQL, if you know how to normalize tables, you should be good. Any other questions? Yes, the midterm will be our chapter 1 through 4 of Cont'd and chapter 6 of Cardinal. What if we don't have other book you took the content from? I put the slide on the Desire to Learn, so if you follow the slide, you should be fine. There is no recording of the sections. Yes, it will be hour and 30 minutes, plus I will give you 5 more minutes to upload that to the Dropbox. Okay. If we are I will briefly go over the quiz. As I said, the quiz high was 16 out of 16 and low was 7.5. So everybody who took the quiz should have the grade on the primarily almost everybody got all the multiple choice questions. The problem that we had was primarily with the SQL statement, and I think a lot of you missed it. And the two questions that I'm going to talk about, which a lot of people missed, was so the first name and last name of all customers were in order with total amount greater than 100. And the mistake that at least lots of people made is, you have select first name, last name from customer, where customer ID in, then you should say select customer ID, because when you say where customer ID in, the next thing should be select customer ID. And I saw, somebody said select, lots and lots of different things. It was not correct. So anybody who thought that they had got it correct and they say why my point is less, that's because that was not correct. When you say where customer ID in, select customer ID from invoice where total amount is greater than 100. So that's what a lot of you missed. Similarly, the second one, select first name, last name from customer where customer ID. Okay, I will upload the correct version of the quiz. I'll do it tomorrow. I'll just I'll just take one on the correct version and pull it out. But a lot of you had a lot of problems with SQL, and some of you, I clearly see you don't know how to write SQL, so you really need to brush up very quickly. and some of you didn't know how to write the sub-query. Those are the two things I saw. The first multiple choice questions were relatively most of you got correctly. The SQL, most of you got it wrong. So that's so a couple of people say that they couldn't follow what I'm saying. Can you explain to me what you didn't follow? What you didn't follow? I think Jennifer says didn't follow. So can you tell me what exactly you didn't follow? Okay. So I will put it up. One thing I could have done, which I have not done, is maybe created a Word document out of it, and we could have put it, but I'll put it up. Okay. So only thing I can suggest is I will put up a correct copy tomorrow, and if after that you can look at yours and you think that you still have a question, send me an email and I can email you your quiz, and then we can talk. Okay. Any other question? I already told the format is going to be long essay type questions and maybe few short answer type questions. There will be no multiple choice. Because it's not fair to be multiple choice questions for an open book and open note and open computer and open everything test. Okay, I don't know how many questions, and but it will be similar to the one that I've done before. So, okay, anything else? I do not have an example of a project. I think I've given enough feedback. Because the problem is that I have to get permission from the people who have done the project to post that, and most of the time I can reach the folks who took the class a while ago. But I'm going to talk to the collaborative people and see how each of you can present. So that's what I'm working on, because the final presentation has to be somehow done, and I'm hoping that there is a way for you to take control and present it. Has anybody taken a class where they have done a presentation with this collaborative team? Anybody knows how to do it? Because otherwise I have to call them. I really don't know. Does anybody know how the students can present at the final presentation and they take over the control? Okay. So I'll ask them if one of the options we have to figure out somehow to present them, and then I'll ask the department if it's a possibility to meet at the end of the semester one day in 2 or 3, but it depends upon whether that's the department policy or not. So all figuring. Yeah, it actually says that the teacher just switch controls to one team at a time. Okay, so then probably we can do that. So I'll just collaborate and figure it out. Okay, anything else before we break for today? And see you next Tuesday at 7:40 for the test. So the question is, okay, so how did it become 16 points? The problem is that chapter 6, 7, 8, 9 was 1 point each. Question number 10 and 11 was 3 point each. And we had 6 multiple choice questions. That makes it 16. Okay, have a good 4th and see you on 9th.